Exercise 4F looks at the applications of differentiation. So you're going to see very similar style questions here to what you have previously, because you know that once you've found the expression for the gradient of a tangent at a point, you may be asked to get the equation of the tangent or the equation of the normal. You might be asked to find where the function is stationary, so you know that your first derivative is equal to naught, etc., etc. I think there'll be no surprises. It'll just be that the functions now involve a trig ratio. So, for example, it says find the equation of the tangent. Equation of the tangent. What do we know about a tangent? A tangent is a straight line. To get the equation of a straight line, there are many different ways. However, we know that most probably the way that we will use will involve the gradient. And let's read on. 2y is equal to 2 sine x at the point. So here we've got gradient, here we've got a point, and we would be using point gradient form. However, all that we have for our point is our x value. So we've got a couple of things to do. We need to get not only an expression for the gradient, but we need to actually work out the gradient, and we need to get the coordinates, the full set of coordinates for the point. So that will involve the y value. I'll pause the video and do those calculations and come back and talk about them. So there's no surprises in this solution. Finding the derivative, simply 2 cos x at x is equal to pi on 6. We're getting that from there. We're able then to calculate the actual gradient, because this is our expression for the gradient. So it's 2 times the cos of pi on 6. I use my little right angle triangle. Pi on 6 is 30 degrees, which sits up here, and cos is root 3 on 2. So it gives me a gradient of root 3. Now, the other piece of information I'm missing is the y value for the point P. So I know that x is equal to pi on 6. To actually get the y value, we use this expression, 2 times sine of pi on 6. And again, pi on 6 is our 30 degrees. Sine of pi on 6 is a half. So our y value is 1. I've got, therefore, given that the gradient is root 3 and P is this. Now, what this does, by putting that statement in, what it says to the marker is, my understanding for the rest of the solution is based on this information here. If I've got any of that wrong, then penalise me back there, but don't penalise me for the rest of the solution, because I'm now working on this information. Always try to communicate as much as possible to the marker about what you're actually doing. So I'm going, given that is the gradient, that is the point, I'm going to use this to get the equation of the tangent. The marker will be in no ways wondering what your thought process is if you set your work out like this. And that's really good, to be able to put the marker at ease about what you're actually doing. It's when the marker has to be, wonder why you might have done something, that they would start to lose interest in your solution, and that is certainly not something that you want. So y minus 1, subbing in root 3. Hopefully I've expanded that out, take them all to one side, and got the equation of the tangent. That should enable you then to do some of the easier questions out of this exercise.